All right, so let's see today, okay? Want to let you know I gave you your quiz back, okay? If you would like to replace a homework or a quiz grade with that quiz grade, because I didn't take it for everybody, if you'll hand it back to me and tell me which one you want to replace it with, I'll replace it, okay? So just let me know at the end of class, hand it to me, and I will change whatever grade you want me to change in the grade book. Okay, that makes sense to everybody? That way, yeah, those of you that did poorly on it, it don't hurt you, and those of you that did well on it, it will help you, because it will replace whatever homework or quiz grade you want replaced. Okay. All right. So today, okay, plans are to go over something new, then review whatever you want reviewed on 7.1 through 7.3. Okay, and then we might have a quiz on 7.1 through 7.3. All right, today is the last thing we're going to cover that's new that will be on your test next Tuesday. Okay, so when you come to class Thursday, we're going to be doing review. All right, we're going to review. I am going to do this. I am going to go ahead and give you the review for the test. Okay? I'm going to go ahead and give you the review for the test. That way, if you want to work on it before class Thursday, you can work on it before class Thursday. And then that way you can say, Coach, I don't understand how to do this problem. I don't understand how to do that. Okay? And instead of us trying to work through every problem on the thing. Okay, I'll start out with number 1 and answer any questions on 1, then answer any questions on 2, and go that route. Okay, hopefully that helps us when we take the test next Tuesday. Okay. Now, this, okay. This is for the test next Tuesday. This is our review. That's what we're going to do tomorrow on Thursday is review for the test. So I went ahead and gave you this. That way you can look at ones you just don't understand. I'll know, hey, we need to go over that one on Thursday. Okay. Also, y'all have, if y'all looked at it, I've already worked them for you. Okay. So you know when you come to class Tuesday, Thursday, you'll know whether, hey, I got a question on that one or not. Okay. So please come with questions Thursday. Right? Don't make me have to create problems for us to do. Hey, because I need help number 1. I'm lost. Okay. We can do that. On this, you made a 4 out of 4, which is 100. What I told them is I didn't take a grade because some of us didn't do so hot, okay? And some of us weren't here. So instead of trying to make it up, I told them, if you want me to replace a grade, homework or a quiz grade, with that grade, which for you would be 100, then let me know after class, and I'll change whichever one you want to change to that grade, okay? All right. So today we are going to talk about 2 things. Okay, really it's the same thing: rationalizing a denominator that only has one term in the denominator, and rationalizing denominators with two terms in the denominator. So we got rationalizing a monomial denominator and rationalizing a binomial denominator. Okay, so here are the notes for that. Okay, there are some notes that are on here. I mean, that are not on there that we're fixing to cover. Okay, so I'm fixing to get a little more in depth and go step by step type of things. Does anybody know Gravon? He's missed last Thursday and today. He plays basketball. Unusual for him anyway. All right. I know he was injured though the last time he came, had a knee or something. So, all right. So today, all right, we want to talk about rationalizing the denominator. Denominator, we're talking about a denominator that has a square root or a cube root. It has a radical on the bottom of the denominator. That's what we're talking about. Okay. So first thing I want to know is how we can make something a perfect root. How to make a perfect root. And this is not in those notes that I gave you. Okay. How to make a perfect root. So I have the square root of 20, which is not a perfect root, right? It is not a perfect root. So, oh, I guess we need to cut that on so y'all can see that, don't we? All right. How to make a perfect root. Go. Heat up and get it where it can show you. All right. So we got the square root of 20. If you put that in the calculator, you'd get a decimal. Okay, if we simplified it, we would do a factor tree, right? 4 times 5. 2 times 2 times 5. Now here's the deal. We want to make this thing be a perfect root. It's a square root. So what do we need to have for it to be perfect? Everything needs to have a pair, right? I got a pair of 2s, but I don't have a pair of 5s. If it was perfect, I'd have a pair of 2s and a pair of 5s. That way I wouldn't have anything left over. So to make this thing a perfect root, I need to multiply by a 5, right? And remember, this is really square root, square root. So that means to make this a perfect square root, I need to multiply by the square root of 5. Because if I do that, now I got 2 2s, 2 5s. So I would get 10 because we do 2 times 5, we get 10. Or if you want to look at it, the square root of 20 times the square root of 5 would be the square root of 100, which is 10. We're making it turn out to be a perfect root. So it has nothing left over. Does everybody understand that? Yes? Okay. So what about if I got the square root of 6? What would I need to multiply by to get it to be a perfect square root? If I got the square root of 6, what would I need to multiply? What square root do I need to make it multiply it by so that I get a number that doesn't have a root? So what can we do? Break the 6 down, right? 2 times 3. To get a perfect root, I need 2 2s and 2 3s, correct? So I need another 2 and another 3, which means I would need to multiply by the square root of 6. because that's multiplying by another 2 and another 3, right? Now, I can sit here, look what I'm showing you. If I got the square root of a number times the square root of the exact same number, I get that number without the square root. Or you can go through all the steps. The square root of 6 times the square root of 6 is the square root of 36, which gives me 6. Okay? Now look, I'll tell you this. I don't know exactly how, if you look at a video from this book, when you go to my math lab, okay, I don't know if they do it this way. Okay, I'm doing it the way I think is the easiest. I haven't looked at how they do it. So if you look at their way, they may be doing it a totally different method. Okay, so if you go look at that, you may be confused. Okay, all right. So let's look at another one. Square root of 12. What do I need to multiply it by to make it become a perfect root? So what are we going to do first? Break it down. 12, 2 times 6, 2, 2 times 3. So what do I need to make it a perfect root? I've got 2 2s. I need 2 3s. So I need to multiply by another 3, right? So come up here and multiply by the square root of 3. Is that making sense to everybody? Because this is going to go to doing something else we're fixing to do next, where we're rationalizing the denominator. So what do I get? The square root of 12 times the square root of 3. That's the square root of 36, which gives us 6. Now I can sit here and multiply these, or I know that I just did 2 times 3 times. So I know automatically this is going to be 2 times 3 and give me 6. Okay? So I really don't have to multiply and get the square root of 36. I'm doing it down here. There's 2 2s, there's 2 3s. So I get 2 times 3, which gives me my 6. From when we were simplifying radicals last Tuesday, I think. Questions from anybody? Ma'am, I'll do another one. Okay. All right. Try this one. The square root of 45. So we're going to break it down, correct? So that's 9 times 5, which is 3 times 3 times 5. So what do I need to add down here to make it be a perfect root? I would need to multiply by another 5, right? So I'm going to come up here and say, hey, multiply by square root of 5. When I do that, that means I've now made it be 2 3s and 2 5s, right? So my answer would be 3 times 5 or 15. I made it become a perfect root. I made it become 15. Questions? None? All right. I'm gonna get a little harder and maybe it'll make you go, oh, okay. And I'm gonna go to cube root. Okay, cube root of 12. Now what do I need? Because it's cube root, I need what? I need 3 of everything, right? Okay, so if I do 12, that's 2 times 6. That's a 2. And a 2 times a 3. Okay, I need 3 of everything now. So what do I need to add to this? I need to add 2 3s to it, right? And I'd also need to add another 2. Does everybody follow me? Because I'm not doing square roots. We're doing cube root now. So now I need 3 of everything instead of 2 of everything. Okay, understand that? So I had 2 2s and 1 3, so I need to add 2 3s to get 3 3s. And I need to add 1 2 to get 3 2s, right? If I multiply all that together, that'd be 3 times 3 is now, I need 18. If I multiply by the cube root of 18, this thing will become a perfect root. Does everybody understand? Because 3 times 3 times 2. Remember, this is what 12 is right here, right? and I need to get 3 of everything because that's a cube root now, not a square root, right? When it was a square root, I needed 2 of everything. Okay, now it's a cube root, so I need 3 of everything. There's 2 2s, so I need another 2. There's 1 3 from 12, so I need 2 more 3s. Make sense? And if I multiply this extra stuff together, I get the 18. You with me? Now, there's no reason for us to multiply 12 times 18. We've already got it down here. There's 12, there's 18. When we multiply 12 times 18, we're going to end up with all this. I made it come up with 3 3s and what? 3 2s. So my answer is 2 times 3, which is 6. I got to speak up now, because I know this can be confusing. You'll be going, what the heck? Try another one. Okay. All right. So what if I go the cube root of 25? Bring it down. 5 times 5. Because it's cube root, I need 3, right? So what do I need? I need 1 more 5. So I come up here and multiply by the cube root of 5. When I do that, if I multiply 25 times 5, I know it's going to break down to this, right? So I know my answer right now is 5. Because that's 3 5s. Questions? None? Try another one. Let me think of one here. Cube root of 24. What are we going to do first? Break it down. What do y'all got? What times what's 24 in y'all's mind? 8 and 3. Okay. So the 8 breaks down to 2 times 4. Bring down my 3. 2, the 4 breaks down into 2 times 2. Comes 3. I need 2 more 3s. Does everybody understand that? So if I multiply by 2 more 3s, that means I'm multiplying by 3 times 3. So I'm multiplying by the cube root of 9. But there's really no reason to multiply 24 times 9 and then do the cube root. I just made it have 3 2s and what? 3 3s. So that would be 2 times 3, which is 6. Questions? Anybody? All right. Let's add a variable here. Okay, what if I got this? The square root of 18x. I want to make a perfect square root now. So take the 18, break it down, right? 2 and 9, 2, 3, and 3. Now, are we looking for 2 of stuff or 3 of stuff or 4 of stuff? 2 because it's a square root, right? Well, there's 2 3s, so I already got 2 of them. I need 1 more 2. So I need to multiply by the square root of 2. Now I got 1x, right? So I need another x too. Everybody agree? So I'm going to multiply by the square root of 2x. If I do that, what do we know? We just multiplied by 2 and x, and we already had an x, right? So now I got 2 3s. Boy, I went to 6 again. I got 2 2s again, right? All right, hold on. I got you. All right. 2, 3 times 3. This is what we already have out of the 18, right? We just added another what? 2. So now I got 2 3s and I got 2 2s. Remember, every time I have 2 of something, if it's underneath the square root, I get 1 on the outside, right? So that means I got a 2 times a 3 left over. I mean, not left over. I got a 2 times 3 on the outside. Nothing left over on the inside, right? Then I got an x and another x, so I got 2 x's, correct? Yeah. So I'm putting x down there. So I end up with 6x. If I multiply this times this, let's do it, because some of you may need to do that. 18 times 2 is 36. X times X is X squared. Okay? So from what we learned on Thursday, okay, 36 breaks down to 6 times 6, 2 times 3, 2 times 3. Square root. So every time I have 2, I get 1 on the outside. So there's 2 2s, I get 1 on the outside. There's 2 3s, I get 1 on the outside. Right? And then we talked about, hey, if it's variables, we can take the root and divide it into the power. X squared. So we divide 2 into 2, we get what? 1 with none left over. So I get an X with nothing left over underneath. You remember that? So when I multiply that times that, I get 6x when I take the square root of it. Okay? Let's go back just a minute. What if I did the square root of x to the 5th? Y'all remember what I told you to do? How do I simplify the square root of x to the 5th? That's where we did 5. There's understood to be a little what? 2. So we divided by what? 2, which goes 2 times and gives me 4, and I got 1 left over. Y'all remembering this? The number that was on the top here, the number that the root went into that became the power on the outside. And then we had the square root, and we got 1 left over, so it's x to the first underneath. Y'all remember that from Thursday? About the variables? Y'all remember that? Okay? Yes? So if we had the square root of x to the 5th, we divided the root into the power. However many times it went became the exponent of a variable on the outside. And what I had left over, I had that same variable with that exponent. So the square root of x to the 5th can simplify to x squared, square root of x. Everybody understand that? Yes? I hope so. All right. So what if I did this? The cube root of 5x. What do I need to multiply it by to get it to be a perfect cube root? All I got is a 5, correct? How many 5s do I need? I need 3 of them, so I need to multiply by 2 more 5s, which would be multiplying by 25, right? 5 times 5 is 25. Agreed? Okay. Then I got 1x. How many x's do I need? 3. So I need to multiply by 2 more x's. So x times x is x squared, right? Excuse me. I'm just multiplying by x. It's going to give me x squared when I multiply. Now, if I multiply this times this, aren't I going to get this when I factor it? So I know right now I got 3 5s. Excuse me. I need an x squared because I need to multiply by 2 x's, don't I? I already got 1 x. Then I need to multiply by 2 more x's, which would be multiplying by x squared. Everybody understand that? So now I've got 3 5s, which is a 5 on the outside. I got 3 x's, which is an x on the outside. Nothing left over. So I get that. Because if y'all don't understand this, we can't go any further. So you got to talk to me. Do we understand this? And what to multiply by? Okay. All right. I've already said for the most part. So let's go to the next thing since nobody else is saying anything. All right. And let's look at the new stuff today on rationalizing with one term. Okay. Rationalizing a fraction, one term. We got something like this. 2 square root of 6 over the square root of 75. Okay. Now here's the deal. The problem says rationalize the denominator. So first thing we need to know, what in the world does that mean? These are what the directions will say when you do them. Okay. First thing, the denominator is the bottom of the fraction. What it means by rationalize, rationalize it means make it where there's not a square root on the bottom. Make it so there is no root on the bottom. I don't want a root on the bottom at all. Everybody with me? I do not want a root on the bottom. So we need to multiply by 1. But we can't multiply by 1. It wouldn't change it. We got to multiply by something that represents 1. So I'm going to take the square root of 75 and I'm going to break it down. 25 times 3. Square root of 5 times 5 times 3. To make it so I won't have a root on the bottom, I need a perfect root, correct? So what do I need to multiply this by? I need to multiply it by the square root of 3. So that I got 2 5s and 2 3s. Does everybody understand that? So if I'm going to multiply the bottom by the square root of 3 to get it so it's a perfect root, whatever I do to the bottom, I got to do to the top, because now, what did I just multiply by if I put the square root of 3 over the square root of 3? What did I multiply by? What value? Anything over itself is equal to what? 1. So I multiplied by 1. It's going to make it look different, but it's not going to change the value. Everybody understand that? Yes? So that is step 1 on your things. Do the prime factorization is step 1. Okay? And then step 2 is multiply by what you need to multiply by to make it a perfect root. Okay? So now multiply that. Okay, I'm going to get 2 square roots of 18 over, and you can do 2 things here. Your choice. It doesn't matter with me. You can multiply the square root of 75 times the square root of 3, which is going to give us the square root of 225. Okay? After you do that, what do you have to do with these 2 roots? You have to simplify them, right? The thing is, the reason I'm saying there's no reason to multiply this times this is because you've already done it right here. Square root of 225, we made it become these 4 things, right? So I got 2 5s, 2 3s. So that's going to be 3 times 5. So the bottom becomes 15. Everybody with me? Square root of 18. 6 times 3. 2 times 3. 3. So what do? There's a pair of 3s. Y'all remember? That makes that become 2, and the square root of 18 is 3 with a what? 2 left over, so we got square root of 2. So now if I multiply that, I get 6 square root of 2 over 15. Okay. So that's step 4, simplify the roots. Okay, so I simplified the roots. Step 5 says simplify the numerator and denominator. Well, I can simplify this numerator by doing 2 times 3 because they're both outside the root to get 6 square root of 2. And step 5 says reduce. 6 and 15 have 3 in common, right? So I can divide both of them by 3 and get 3 square roots of 2 over 5. And that's the hardest problem you're going to have here, because you had to do every single step. There'll be a lot of them that you get to skip 2 or 3 steps. Okay, so talk to me right here. What is it that's blowing your mind? The fact that I multiply by the square root of 3. Do we understand that? The square root of 3 over the square root of 3. We got that part. Because that's what we've been doing for the last 15 minutes, right? What do I need to multiply that square root by to get it to be a perfect square root so I won't have a square root on the bottom? Okay? That's the objective. When it says rationalize the denominator, get it so it will not have a root on the bottom. So make it become a perfect root on the bottom. Everybody with me? Yes? Then from there, you're just simplifying. Multiply that times that, I get that. 2 square root of 6 times the square root of 3, 2 square root of 18. We good there? Okay. Square root of 75 times the square root of 3, square root of 225. Okay, but really, there's no reason to multiply and just get this 225 because we chose this 3 so that we would get 2 5s and 2 3s, right? We chose it that way. Agreed? So you could skip this and just go, okay, I know 5, this is gonna have 2 5s and 2 3s, so I'm gonna have 3 times 5. I'm gonna have 15 for the bottom. I'm making it become that way. Everybody understand? Yes? So you won't have to sit here and simplify the bottom and the top. You really just need to simplify the root on the top. If it'll simplify. Well, it's simplified to 2 3s and 1 2, so we got a 3 on the one outside with a 2 left over on the inside for the square root of 18. Everybody with me? So now I got 2 times 3 squared is 2, so I get 6 squared is 2. Because remember, we only multiply what's on the outside times what's on the outside, right? Okay? And what's on the inside times what's on the inside. When we multiply radicals. Okay? And then we got to reduce 6 over 15. Don't worry about the square root of 2. 6 over 15, what's it reduced to? Okay? 3 goes to 6, 3 goes to 15. By 3 by 6, I get even. Y'all didn't catch me. I'm wrong. I'm wrong. How many times 3 go into 6? 2 times. So instead of having 3 squares to 2, I should have what? In other words, right here, we're dividing the 6 by 3 and the 15 by 3, right? 6 divided by 3 would be what? 2 right there. So I should have 2 squares of 2 over 5. Okay? Everybody understand? Yeah, teacher can make a mistake too. All right? Any questions? Okay. Did I make the same mistake on my paper? Nope. Just when I worked it here. Okay, 2 squared is 2 over 5. Any questions? All right, let's try another one. Like I say, that's the hardest one possible. Okay, let's go with an easy one. Okay, the square root of 5 over the square root of 2. Remember, the directions say rationalize the denominator. Rationalize the denominator. So I need to get this so it has 2 of everything since it's square root. Does 2 break down? Come on. This class is so much more fun if y'all speak. Well, 2 break down. No. So what do I need to multiply to make it be 2 of them? 1 more 2, right? So multiply by the square root of 2 over the square root of 2. Everybody understand that? So I'm fixing to multiply this by the square root of 2 over the square root of 2. That way I'll have 2 2's on the bottom. So I know that will be simply 2. And the top, the square root of 5 times the square root of 2 is 10. Try to get the square root of 10 over 2. And if you don't like, let's not skip the step. I skipped the step. Square root of 2 times square root of 2 is the square root of 4. Which gives me the square root of 10 because it doesn't break down over 2. I'm trying to make it where you don't have to worry about breaking down. We're making it become 2 by making it 2 2's. Questions? That's an easy one because 10 won't break down. It's just 2 times 5, right? Doesn't have 2 of anything. So it's as simple as it can get over 2. Can I reduce that? No, because they're not both on the outside, right? Everybody understand that? I can't go, well, 2 goes to 10. Nope. That 2 is underneath the root. Okay? I can only divide and multiply. Root times root. Okay? And number on the outside, number on the outside. I can't do inside, outside. Any questions? Try another one. All right. We will try another one here. Let's see. I'm not going to do this one. I'm going to let y'all try this. 9 over the square root of 20x. 9 over the square root of 20x. So first thing I need to know is what do we need to multiply by? Rationalize the denominator. What do we need to multiply by? Okay, the 20 breaks down into 5 times 4, right? And the 4 breaks down to what? 2 times 2. All right, so this breaks down into 5 times 4, 5, 2 times 2. So what do we need to multiply by? The vertex has got it. We need to multiply by 5 so that I will have 2 5s and 2 2s. I also don't have it. How many x's? 1, because that's x to the first, right? I need 2 of everything, so I need to also multiply by a x. So if I'm going to multiply it on the bottom, I got to also multiply it on the top. Questions? We sure? So now I'm going to do the math. 9 times the square root of 5x, that's on the outside. What's on the outside of 1? So 9 times 1 is 9. So I got 9 square root of 5x. On the bottom, I got what? 2 5s and 2 2s. So I got 10. I got 2 x's. So I got x. That's my answer. It won't reduce. I don't have to go any further than that. Can't do anything with 9 square root of 5x, and nothing 9 and 10 don't reduce. That is my answer. Y'all got to speak to me now. I got one person that I know knows how to do it. What about the rest of it? Questions? None? Okay. So let's try this one. Okay. Square root of 2x over the square root of 63x. So we know we're going to multiply by a fraction. What fraction are we going to multiply by? Got to figure out, well, we got to have 2 of everything, right? 63, what's it break down to? Come on, folks, help me out. What times what is 63? Nine times 7. 63. Then we got 9 breaks down to 3 times 3. So what do we need? We need a 7. So we're going to multiply by the square root of 7. We also need to multiply by an x. Everybody with me? Okay, so we're going to do it to the top and the bottom, right? Questions? So on the top, what do I get? The square root of what? 14x squared, right? And on the bottom, we added another 7, so we got a 3 times a what? 7. So we're going to get 21 down there. And then we got an x times an x, so we're going to get an x. Because remember, this is really square root of all that, right? I need 2 to make 1 on the outside. Questions? Now simplify. 14, does it break down? Yeah, but just a 2 times 7. I don't have 2 of anything. But the x squared, that's 2 x's. So I can get an x on the outside with no variable left in the middle and 21x. Now what can I do? Got an x on the top outside and x on the bottom outside. What do? They factor out, they cancel. So my final answer here is the square root of 14 over 21. Questions? Questions? Can you do one? Any questions? All right. You good? You sure? Okay. King, we good? right? Because that's that. I really want to go, what if we got a binomial on the bottom? What if we got two terms on the bottom? What we do? Okay? So here's what I want to look at. Before I look at that, I want to look at this. What is the square root of 3 minus the, let's go 2 square roots of 5 times the square root of 3 plus 2 square roots of 5. We did this last week. On Thursday, we learned how to multiply those like that. Y'all remember how to do it? Okay, so here's what, remember, binomial times binomial, we got to do the foil to it, or the claw if you want to think of it, because that looks like a claw, okay, a crab claw. So we do the square root, when we draw this line, that's the square root of 3 times the square root of 3, right? What's the square root of 3 times the square root of 3? It'd be the square root of what? 9, right? Because 3 times 3 is 9. Then I do the square root of 3 times 2 square roots of 5. That's going to give me 2 square root of 15. Everybody with me? Yes? Then I'm going to start with the negative 2 square root of 5 times the square root of 3. That's going to give me negative 2 square root of 15. Then I'm going to do negative 2 square root of 5 times a positive 2 square root of 5. Well, negative 2 times negative 2 is negative 4. A square root of 5 times the square root of 5 is the square root of 25. Now, I'm going to tell you this. I would like for y'all not to have to do that total step. Here's what I want you to realize. If I multiply the square root of a number times the square root of the same number, you know what I get? I get that number without the square root. Because what's the square root of 9? Isn't it 3? I was multiplying the square root of 3 times the square root of 3, and we ended up with 3. Because the square, that was 9. Have I understand that? So every time you're multiplying the square root of a number times the square root of the exact same thing, you get that number without the square root. Then I got what? We're going to write plus 2 square roots of 15 minus 2 square roots of 15, because right now we're just simplifying the roots. What's the square root of 25? 5 times 5, so that's 2 5s, correct? So that means the square root of 25 is 5. So really, I could have skipped right here. I could have skipped this step. I knew the square root of 3 times the square root of 3 was going to be 3, and I did 2 times 2 is 4. Square root of 5 times the square root of 5 is 5. I could have automatically gone from there to there. Now, what we get? 3 plus 2 square roots of 15 minus 2 square roots of 15 minus 4 times 5 is 20. Now look what I got. I got like terms, right? Positive 3, negative 20. That's negative 17. What does 2 square roots of 15 and a negative 2 square roots of 15 make? You're right, nothing. They make 0. Look what I now have. I have something without a root.
17,
Negative 17 is my answer. I don't have a root anymore. So that's what our next thing to do is to be able to get a root if something's being added or subtracted. So I want you to look, what is being multiplied? What do you notice about these two parentheses? What do you notice about both of them? What do you notice about both of them? Aren't they exactly the same? Except for the sign in the middle? If you have two binomials where one is exactly like the other one except for the sign in the middle, you're not going to end up with a middle term. So everybody listen to me, because I'm trying to save you some time here if you'll listen. and pay attention and not apply this to every single problem there is. This only works if you have no, I need to come on. The exact same thing in both parentheses, except for the sign in the middle is different. This is called the conjugate of this. Or they're the conjugate of each other. Okay, what's a conjugate? It means they have the exact same first term, the exact same last term. The only thing different is the sign in the middle is different. Okay, if you do that, you don't have to do that whole clause. Everybody listen to this? If you have the conjugate of something and you're multiplying by it, you don't have to do this, 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 and this. You don't have to do all four. Okay? All you have to do is this. Multiply the first times the first and the last times the last. That's all you got to do. Okay? Because the other part's going to end up being 0 every single time. The other parts end up being 0. So all I got to do is 2 squared root of 3 times 2 squared root of 3. That's 4. And what did we just get through saying? The square root of 3 times the square root of 3 is going to be what? What's the square root of 3 times the square root of 3 going to be? 3. Now, if you can't remember that, then do it. It'll be 4 square roots of 9, right? But what's the square root of 9? 3. Okay? Then we got what? The square root of 5 times the square root of 5. It's a negative times a positive, so it's going to be a negative. What's the square root of 5 times the square root of 5? 5. You are correct. Or if you can't remember that, hey, multiply them. That gives me the square root of 25. Well, the square root of 25 is what? 5. So now I got 12 minus 5. I got 7. 7's my answer. But it's important that you understand this only works if these are exactly the same, except the sign in the middle. One's positive, one's negative. Then I can skip doing the full part, the outside and the inside part. I can just do the first times the first and the last times the last. Does everybody understand that? But it's got to be special like that. Okay? So this is the conjugate of that. So let's talk about something before we go any further. Okay? I got this. 2 plus the square root of 3. Okay? Tell me, what's this conjugate? What is the conjugate of that? Because that's easy now. I just told you what it was. Talk to me. What did I say to do? It's the exact same thing that's right here, 2 and the square root of 3. Except this has a plus in the middle. The conjugate will have a what? Minus. That's it. That's the conjugate. Okay. I got this, negative 2 square roots of 7 minus the square root of 5. What's the conjugate of it? I'm going to write negative 2 square roots of 7, right? I'm going to write the square root of 5. And I'm going to change that to a plus. Everybody understand? So everything is the same except for this sign in the middle. That's the conjugate. Okay, I go negative 3 square roots of 2 plus 5 square roots of 11. What's the conjugate? All right, same thing, negative 3 square roots of 2, 5 square root of 11, but put a minus sign. Questions? Okay. I'm hoping so. Because here's how we're going to do one where the denominator's got two terms. Okay, got two terms. We got something like this. 8 over 3 minus the square root of 11. 8 over 3 minus the square root of 11. Again, the problem says rationalize the denominator. Okay, if it says rationalize the denominator, what did it tell us to do a while ago? Make it so we don't have a square root on the bottom, right? So I want to get rid of that square root of 11. Okay, and because that's a binomial, I can't go just multiply by the square root of 11 over the square root of 11. I got to multiply by the conjugate. What's the conjugate of the denominator? That's exactly it. 3 plus the square root of 11. Everybody with me? So I'm going to multiply these. 8, and here's the deal. I'm not going to multiply this 8 first. That's just going to be 8, 3 plus the square root of 11. We're just going to write it just like that. 8 times 3 plus the square root of 11. If I am multiplying this times this, what do I have to multiply? Somebody tell me. I had to multiply the 3 times the what? 3. That gives me 9. Then I got to multiply what? The negative square root of 11 times the positive square root of 11. That's it. So that's going to give me negative 11. From here on out, let's do the math. Okay, I got 8 parentheses 3 plus the square root of 11. What's 9 minus 11? It's negative 2, right? And here is why we didn't multiply by that 8 first. What can you now do with that 8 and that 2? I can cancel it because 2 goes to 2 one time, 2 goes to 8 4 times. So I really got 4, negative 4, because we're just going to move the negative up to the top. Okay? Times 3 plus the square root of 11. Okay, and I believe your Math Excel will let you leave it that way. Okay? If it's multiple choice and you don't see that, then they may have done this. They may have distributed the 4. Made it negative 12, and the negative 4 times understood to have a 1 there, so that'd be negative 4 square root of 11. So either one of those answers is acceptable. Okay? If it's multiple choice, they're going to show you which one they want. Okay? If they show them all multiplied out, then multiply it out. I will accept either one of those if it's not multiple choice. Questions? So all I'm doing is multiplying by the conjugate to get rid of the denominator on the bottom. Okay? Try one more here. The square root of 6 minus the square root of 7 over the square root of 6 plus the square root of 7. So again, the directions say rationalize the denominator. Get rid of that denominator. So what am I going to multiply by? What fraction am I multiplying by? Well, at least I'll be able to tell me that. I'm multiplying by the square root of 6 minus square root of 7. Yes, on the top and the bottom. Is everybody with me? Yes? Let's multiply the bottom first, then we'll worry about the top. Okay? So on the bottom, I got the square root of 6. Since this is the conjugate of this, all I got to do is the first times the first, which is going to give me 6, and the last times the last, which is going to give me negative 7. Talk to me. Did I lose anybody doing that? We've made it be that way. So I only do the first times the first and the last times the last. Square root of 6 times square root of 6 is 6. Square root of 7 times square root of 7 is 7. Now, can I do that to the top? Can I just do the first times the first and the last times the last? Nope. Because they're not exactly the same except for the sign in the middle. They're exactly the same, right? So I got to do that whole claw thing. Okay, I got to do the 4. The square root of 6 minus the square root of 7 times the square root of 6 minus the square root of 7. Square root of 6 times the square root of 6, 6. Okay, or I can put the square root of 36, but the square root of 36 is going to be 6, right? Then the square root of 6 times the square root of 7, that'll be a negative square root of 42. Then a negative 7 times the square root of 6 will be another negative square root of 42. Then a negative times a negative is a positive. Agreed? And the square root of 7 times the square root of 7 is simply the square root of 49 or just 7. Everybody with me? Now, combine the like terms. So I'm going to go ahead and write this. I got 6 square root of 42 minus square root of 42 plus 7. Now on the top and the bottom, I need to combine the like terms, right? I got a positive 6 and a positive 7. That's 13. These are understood to have a 1 in front of them. So a negative 1 square root of 42 and a negative 1 square root of 42 is negative 2 square root of 42. And 6 minus 7 is negative 1. Everybody with me? Yes? Okay. I need to see, does the square root of 42 break down? That's 6 times 7. That's 2 times 3. So square root of 42 doesn't have 2 of anything, so it stays the square root of 42. I'll take this answer, or you can, since there's nothing but a negative 1 down here, just divide negative 1 into everything. Try to get negative 13 plus 2 square root of 42. Does everybody understand that? The last part, how it changed from this to this. You divide by negative 1 divided into 13 gives you negative 13. Negative 1 divided into negative 242 gives you positive 2 square root of 42. Questions from anybody? We sure? How frustrating. All right. I'm going to skip to this one over here. Yeah. So number 5 on your notes. Okay. 2 square root of 2 plus the square root of 10. 4 square root of 2 minus the square root of 10. So talk to me. What am I going to do first? Y'all talk to me, please. Let me do what y'all tell me to do. Four square root of 2 on top and bottom. What else? It's minus square root of 10, so we're going to put what? Plus the square root of 10, because we put the opposite. That's what I'm multiplying by on top and bottom. Okay? And now, since these on the bottom are exactly the same but opposite signs, I can just do first times first and last times last. So 4 times 4 is 16. And the square root of 2 times the square root of 2 is 2. So I get 16 times 2. Talk to me. Does everybody understand that? Then I got negative times a positive, so I'm going to get a negative. And the square root of 10 times the square root of 10 is 10. Any questions on that? Okay. Then I'm going to do this times this. Well, 2 times 4 is 8. Square root of 2 times the square root of 2 is 2. I could put 8 square root of 4, right? But no reason to do that. I know 2 times 2 is going to be 2 out of the square root. Then I'm going to do 2 square root of 2 times this, which is going to give me plus 2 square root of 20. Everybody good with that? So now I've done this to both of them. Now I got to do the square root of 10. The square root of 10 times that would be plus 4 square root of 20. And the square root of 10 times the square root of 10 would be plus 10 without the square root. Any questions? So now it's about doing math and simplifying this problem. I can do 8 times 2 and get 16, plus 2 square roots of 20, plus 4 square roots of 20, plus 10, over, I can do that times that and get 32 minus 10. Okay, bringing it up here. Now I can combine the 16 and the 10. Gives me 26. And I can combine these square root of 20s with square root of 20s. So 2 plus 4, that's 6 square root of 20. Because when I add, the roots have to be the same, and I just add the numbers on the outside. Over 32 minus that is 22. Now, what have I got to do? I always got to check and see if the square root will simplify, right? Well, 20. That's 2 times 10. That's 2. That's 2 times 5. So that means it's got 2 2s. So it changes to 2 square roots of 5, right? So that means I can get 26 plus 6. Square root of 20 is 2 square roots of 5 over 22. Okay? Everybody with me? So then I can, okay, 26 plus 6 times 2, that's 12 square root of 5. Okay? Everybody with me? Yes? So now, here's where this one becomes a little bit different than the others. Y'all look at the 3 numbers on the outside. You got 26, you got 12, and you got 22. Well, anything go into all 3 of them. Is there a number that will go into 26, 12, and 22? 2, because they all end in an even number, right? So I'm going to reduce this thing by dividing everything by 2. Okay? Now, I will tell you this. My directions, my steps tell you to do something else. Okay? I'm teaching, this is another way of teaching it, and I'll teach it both ways. 2 goes. So I'm going to divide 2 into 26. I get 13. I'm going to divide 2 into 12 and get 6 square roots of 5. And I'm going to divide 2 into 22 and get 11. Okay? Everybody with me? That is my final answer. Now, if you follow the steps on my paper, here's what I did. Take the top and factor it. 2 goes into both of them. So divide 2, I get 13 plus 12 square roots of 5 over 22. And now 2 are going to both those. I get 1 out here with 11, which gives me the exact same answer. 2 different ways of doing the exact same thing. Instead of just dividing 2 into everything, I factored the 2 out of the top. Then it'll cancel. Does everybody understand that? Either way you want to do it, it doesn't matter with me. Factor the greatest common factor, then divide, or just divide 2 into everything. Or whatever goes in everything. None of the other problems we had anything that all 3 would go into. Okay? Any questions? We sure? Okay. All right. So any questions on 7-4 from Thursday? Which basically we've kind of done it. Because it was about multiplying and adding and subtracting roots. Any questions on any of the homework, 7-1 through 7-4, any of that stuff? Is that none? I must be blowing this stuff out of the water. All right.